A point on the terminal side of an angle theta is given. Find the exact value of the other 6 trig functions. What they mean by the terminal side is that every angle in the unit circle starts right here and it swings open. So like the point 3, negative 3, which is here, technically speaking, even though the angle is here for the point 3, negative 3, that angle on the unit circle would be this. However, we're not going to draw our triangle like that. How are we going to draw the triangle? How do I connect this? X-axis, put in your right angle, put your theta in the origin, and just like we've already done, your coordinate will give you the x and y portions. This is 3, this is negative 3. Can somebody tell me what my hypotenuse is going to be? Very good. 3 radical 2. Now we just need the 6 trig functions. So I'm going to go ahead and draw those out. Then we'll just fill them in and we're done. Again, did this last week, but we're going to do it again today. So for practice. Okay, here we go. Justin, what's sine of theta going to be?
-3
Over?
-1 of -1. What? What did you say? Sine of,
What did I say?
yeah.
Sine of theta.
And then -3 over 3 over -3.
It's
And you work that out.
very good. -3 over 3 radical 2. Now, because I'm low on space for this example, I'm just going to leave it like that, but you will have to rationalize it by multiplying the top and bottom by radical 2. Well, the 3's would already cancel, I guess. And it'd be -1 over radical 2, which you'd still have to rationalize. But I'm low on space, so I'm not going to do that. Cosine of theta. Latifa. Over. This isn't the unit circle. You have to give me adjacent over hypotenuse.
Oh, okay. So,
Yes.
okay. 3 over 3 radical 2.
Very good. Again, you could reduce that and rationalize, but for the time being, just because I'm low on space, we're going to leave it like that. Tangent of theta, Nate. Very good. -3 over 3, which reduces to -1. So for the other 3, what's the only thing we have to do, Lazarus? Swap them. 3 radical 2 over -3. Again, you could simplify that. 3 radical 2 over 3. Again, that would simplify. And what's -1 flipped? -1. Very good. That's all you have to do. You will need Pythagorean theorem to find your hypotenuse, but that is it. Is there another example on the board that somebody would like to see? No? Okay, here we go then. In exercises 17 through 22, let theta be an angle in standard position. Name the quadrant in which it lies. So all you need here is the quadrants, and hopefully you have in your unit circles where we made that plus, 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 and minus, plus, minus chart thing. In what quadrant is both the sine value is negative or positive and the cosine value is positive? Very good. Quadrant 1 has both of them being positive. In which quadrant is sine negative and cosine negative? 3. Or you can give me it in Roman numeral. And in which quadrant is tangent negative and cosine negative? 2. 4 has sine negative and tan negative. These are all straight from your unit circle. Now I can pull up unit circle and show this if someone would like that. Okay. Let me have 2 seconds. You would think by now I would just have a unit circle. What am I doing? I don't want to go to Butler's basketball pitch. What's he doing? Who knows? In quadrant 2 and 4, tangent is negative. Okay. All right. Unit circle images. This one will work. No, that's a horrible one. This one will work. Ooh, that's much better. How you doing? So now on your unit circle, if you don't have this, you should put it on there now. In the first quadrant, cosine is positive, sine is positive, and tangent is positive. Positive, positive, and since tangent is just sine divided by cosine, if they're the same, then they're going to be positive. In the second quadrant, looks like our cosines are negative, our sines are positive, and since tangent is sine divided by cosine, what's a positive divided by a negative? Negative. Third quadrant, cosine's negative, sine's negative, therefore tangent would be positive because a negative divided by a negative. And in the fourth quadrant, cosine is positive, sine is negative, and this tangent is negative as well. That's the only thing we're doing right there. So like the one that said sine is negative, cosine is negative, so you're looking, which one has two negatives here in the beginning? Quadrant 3. That's why it was that answer. That's the only thing you're looking at on those problems. Any further questions about these? About where we got something? Okay. Same difference. Find the exact value of each of the remaining trigonometric functions. Tell you what, we're actually going to start with 31 for a specific reason. Okay, so just like we did last week, if they give you a trig function with a ratio, what is that really telling you? Who's it telling you? They say sine of theta is 2/5. What does that mean? Yeah, you draw a triangle, and if sine is 2/5, that means your opposite is 2, and your hypotenuse is 5. So Fitoa. So why are they giving us the second thing? Well, let's look, and I'll tell you. All right, so they say tangent is 4/3. So let's just draw ourselves a triangle. We'll make this theta. Tangent is opposite over adjacent, so opposite, adjacent. You do Pythagorean theorem and find that your hypotenuse is 5. However, the reason they're giving us these is to let you know which pieces are negative. Tangent is 4/3. So 4 and 3. But what else would give us? What other values in these two spots would still give us tangent of 4/3? -4, -3. Very good. These could have been negative. So how are we going to know which ones are negative? That's why they're giving you the second piece. That's going to tell you which quadrant you're in. So which quadrant has positive tangent values but negative cosine values? Just like we just did. Look at your circle. Quadrant 3. So I probably should have drawn this down here. Well, that's really horribly drawn, but whatever. Right angle, theta, tangent is 4/3. But because we're in the third quadrant, we know that they both have to be negative. Therefore, your hypotenuse is 5. And once again, all you're doing is giving the trig functions. No, your answer is the 5 remaining trig functions. So for this one, it would have been sine, cosine, cosecant, secant, and cotangent. But all I'm starting with right now is showing you how to know which pieces are negative and which pieces are positive. That will come from the second step every time. Let's look at another one. Let's see. So 23, also in the third quadrant. Here's how I would personally do this if I were you. I'd come put some random point out here in the quadrant that it implies, and then I'd connect it. Make it into one of my little circular thingies. Now what's it telling me? Sine is -3/5. Ashton, cosine. What's cosine stand for? Adjacent over hypotenuse. Now it tells us that the whole thing is negative. Which piece has to be the negative part? The 3 or the 5? The 3. Yeah, it does matter. The hypotenuse will never be negative, and in the third quadrant we know that cosine is negative, so our x. What's our last piece going to be? How can we solve for it? Pythagorean theorem. A squared, you don't have to worry about the negative since you're just squaring it anyway, plus b squared equals c squared. 9 plus b squared equals 25. Subtract. Square root. And what is b? What is b? Well, it's in the third quadrant, so we know it's negative. Use the quadrant to tell you what's positive and what's negative. Now from here, all you have to give me is sine of theta, tangent of theta, because cosine was already given, cosecant theta, secant theta, and cotangent of theta. So, what would sine of theta be? Negative 4/5. What would tangent of theta be? Negative 4 over negative 3, which would just be 4/3, which is why it's going to be the exact same as number 31. Cosecant. Secant. Negative 5/3. And cotangent. Muy bien. Very good. Raise your hand if you have a question about where in the I don't really know where I'm going with this, but where we're getting any of these numbers. Which quadrant is 27 implying? Fourth. Very good. Between 270 and 360 is the fourth quadrant. Is there another one on here somebody would like to see? What about 33? What is secant the flip of? Cosine. So what quadrant has negative cosine, bless you, and positive tangent? Very good. If you can figure out what quadrant you're in, then everything else should kind of fall into place. Is there another problem somebody would like to see set up, even if that one is it? Negative 3, what would that be as a fraction? Negative 3 over 1. Just don't forget that. Okay. Reference angle. These are so simple, but they do require a little bit of explanation. Let's get back to this last problem for a minute. Actually, hold on. Dadgum. None of these are really what I was going for. Okay, here's a question. If I told you to draw a 330-degree angle on your unit circle, right? You'd be like, well, let's see. It draws all the way around here and it stops here. 330, right? But if I asked you to make that into a triangle, would you give me the 330 right here? Or would you connect it right here? What would this angle be? It would be 30 degrees. If the whole thing was 330 and the whole way around is 360, what is that? That's 30. That is called your reference angle. It's the direction. The reference angle is nothing more than the shortest distance between your angle and the x-axis. So up here, it would be this angle. Down here, it would be this angle. It's just the shortest distance between where you are and the x-axis. Now, I'm going to give you a cheat sheet for finding the reference angle. Not that you couldn't just use that logic all the time, but here's a cheat sheet. We're going to call it the reference angle chart. This will not be on your quiz tomorrow. It will be on your second test over this stuff. The reference angle chart all is depending on which quadrant you're in. So, quadrant. Actually, you're going to have two columns, the quadrant and then how you will find your reference angle. So, quadrant 1, 2, 3, and 4. Now we're going to start in degrees. When you're in the first quadrant, your reference angle is your angle, because that's the quickest way to the x-axis. 45 degrees, well, that's your 45-degree angle. When you're in the first quadrant, your angle is your reference angle, so it's just theta. When you're in the second quadrant, like at 125, your reference angle is 180 minus theta. So like if you were at 125 degrees, your reference angle would be 55. Just subtract. If you're in the third quadrant, it's theta minus 180. And just like Ryan did on that very last problem, when you're in the fourth quadrant, it's just 360 minus theta. And that's it. Now, technically speaking, it's the same exact formula for radians. It's like for 49, 55, 57, and 59. However, 180 isn't in radians. So here's the same exact formulas should you be in radians. Theta, pi over 2 minus, not pi over 2, pi minus theta, theta minus pi, and 2 pi minus theta. That is the exact same formula, but in radians. You will have to find coterminal angles for most of these first. You have to find your coterminal before you can figure out what quadrant you're in. 35. What quadrant is that in? 2. 160. Oh, you meant, I got you. Yeah, I got you. 160 is in the second quadrant, so therefore what's my reference angle? 180 minus your angle? 20. It's all in the chart. Let's just do all the degree ones first. Negative 150, what do I have to do to that first? Nice vocab. Coterminal. Add 360, which is what? Which is what? 210, thank you. What quadrant is that in? So therefore my reference angle is? 210 minus 180, 30 degrees. Third quadrant, there's your formula. 47, what's the coterminal angle to that guy? Very good. I'm gonna pick on specific people on the next one. Very good. Add 360, you get 25, which is in the first quadrant. In the first quadrant, your angle is your reference angle, so just 25. Kevin, what do I have to do to 51? That's exactly what you have to do. And what do you get when you do? Which quadrant is that in? Therefore, my reference angle is? Very good. Muy bien, sir. Very, very good. That are all the degree ones. Questions on those before we bump over to radians? Great.
I'm kind of confused on when you get this volume from I get to the reference angle.
Okay. Well, 35. Does that one make sense? Okay. It gives you the angle, right? So 160 on the unit circle is, if you were to open it up, right here, right? The reference angle is the quickest distance between your angle and the x-axis. So 160 is in the second quadrant, second, so you come over and use this formula. 180 minus 160, 20. The angle is given to you. The only thing you might have to do is find a coterminal that's you know, between 0 and 360 or between 0 and 2 pi. Does that clear it up? Great. 41. Holly, what quadrant is 7 pi over 4 in? The fourth. Therefore, I use which formula? Which would give me what for a reference angle? Very good. 2 pi in terms of fourths is 8 pi over 4, so she subtracted 8 minus 7, got 1 pi over 4. Very impressive. Hey Jordan, what quadrant is 5 pi 6 in? Now I don't know that it's on unit circle. Very good. Being in the second quadrant, what formula do I use? Theta. That's right. So pi minus 5 pi over 6. I need a common denominator, don't I? But 1 pi, how can I make 1 into 6? Yeah, 6 over 6. 6 pi minus 5 pi is 1 pi over 6, and that is your reference angle. Pi over 6. Leslie, 23 pi over 4. What do I need to do? That's exactly what we need to do. Subtract 2 pi. Now what do I need to do? That's exactly what you're going to have to do. Hey, now it looks a lot like number 41. What quadrant is that in? Therefore I use what? Very good. And your reference angle would be very, very good. Yes, miss, sir. Good question. But I'm going to come back to that one in just a second. First off, 59. Gianna, what do I need to do? Exactly. Which is how many sixths? How many? Very good. So that gives me negative 13 pi over 6. Now what do I need to do? Add it again. Which gives you negative 1 pi over 6. Now what do I do? Very good. Do it again. Sometimes you have to do this for a little bit. You get 11 pi over 6. Which quadrant is that in? Therefore I use which formula? And when you do that, who can tell me what I'm going to get? Very good. Pi over 6 is your final answer. Questions about our process here? Because after she added, added 2 pi 3 times. 2 pi would be 12 pi over 6. So 12 minus 11 is 1 pi over 6.
Well, how come like on 43 instead of before?
40.
Oh, it's a different one. Okay. I'm good.
Yeah, it all depends on.
Oh, yeah, I'm good.
All right. Now, 49. You asked about 49. No pi, but is there a degree symbol?
No.
No. So it is a radian. So you have to think about this. What is pi, like as a decimal? 3.14. So I know it's greater than pi. Somebody punch 3 pi over 2 into your calculator. Let me know what that is. You're going to have to look at it as a decimal. 4.7 what? 4.71? Is this less than that? So less than 3 pi over 2 would make it barely in the third quadrant, right? Yes. Okay. So only way we know radians is in pi, right? But you know what pi is. Pi is 3.141 blah 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 in your calculator.
Oh, I think so.
So you can find out what those decimal values are, and somebody just said that 3 pi over 2 is like 4.71, which is greater than this, which means our angle is going to be ever so slightly in the third quadrant, which means I use this formula. 4.7 minus pi, and yes, you'll get a decimal for that one.
So if you get anything like that, you think you're watching on pi.
Yes. And because there's no pi or degrees, somebody actually punched that in for me. 4.7 minus pi. 1.5 what? 1.58. Now, there's no pi, there's no degree, so it would be very helpful if you wrote radians. Because don't forget, you're giving me an angle. And saying an angle is 1.58 is going to confuse a lot of people. So that's why I say radians, and now clear it up. Questions about anything you see on the board?
Yeah. Can you do like the fourth quadrant, subtract the 2 pi?
You mean do one like that?
Yeah.
Well, this one was like that. Because after we found its coterminal counterpart, we got 11 pi over 6, which is in the fourth quadrant. Then 2 pi minus 11 pi over 6. So you have to match the denominator and then double it for the numerator. So 12 pi minus 11 pi gave us 1 pi. Yeah, that's the fourth quadrant problem. Sure. Unit circle. Okay? Unit circle. Now, our radians are in pi. Darn. So if we were to convert those to decimals like that problem was, this would be 3.1415, whatever, right? This would be 6.28 for 2 pi. pi over 2 would be like 1.57 whatever. And 3 pi over 2 is 4.71. So just like degrees, you're saying where does 4.7 lie? It's between 3.14 and 4.71. That's all we did. They're tricky to, I can see that they're tricky. Gotta do what you gotta do. Questions? Alright. Then I'm going to skip on ahead. Let's see. Use reference angles to find the exact value of each expression. So, well, actually, every one of these is on the unit circle. So, let me reword those directions. Just find the expression. Don't use a calculator. So, like, number 86. Number 86, it's just coterminal. We're going to have to do coterminal a whole lot. You're going to have to add 12 pi over 6 like 3 times. And then you'll eventually get down to sine of pi over 6. What is sine of pi over 6, somebody, on your unit circle? 1/2. You just gave me a degree. Yeah, you gave me, yeah. So, I don't know why you don't need the reference angle to do any of these. All you really have to do is find their coterminal counterpart and then just evaluate it. You don't need a reference angle at all. Questions? Is there another one of these somebody'd like to see? 73. Sine of 240. What do I need to do to that? Add 360. So that's going to be sine of 120. And what is that on your unit circle? Thank you. What about 69? Who can tell me how I'm going to do that one? 69. Sam, you should know this one. Who can tell me how I'm going to do 69? Yes, ma'am. Which is what? What is sine of 7 pi over 6? Negative 1/2. Then what do I do to it? Just flip it over. Very good. Cosecant is the flip of sine. Negative 2 over 1. Questions about any of those? You're just going to have to do a whole lot of coterminal. These, I'm not even going to bother with these. These are the same thing. I'm probably going to cut them out. All you had to do was find these on the unit circle. We did them last week. It's just kind of an algebraic headache. You know how to do them. Just you might have to do some common denominators and such. Same thing. Oh, these aren't too bad. But no. Okay, so I'm going to change this to... I don't know. If anybody wrote a book that had 860 problems, that person needs a life. All right.
Why is there a giant chili pepper on our book?
Because Jeffrey Blitzer, the author of your book, always decorates his textbooks playfully. I only know that because I worked at a textbook store. Why not a chili pepper? That's your opinion. Actually, the chili pepper is eerily reminiscent of the integral sign that you will use at the very end of this class. Anyway, this is section 4.4. Section 4.4.